This video will work through the process for tracking the motion of a moving object in Tracker in the context of a mass being lifted by a motor. After opening Tracker, click on Video, then Import. For this example, we will use the file 100grams_run20 from the shared folder in the link in the video description. Right-click on the video or click the film clip icon to adjust the frame rate for the video. This video was recorded at 240 frames per second, so we need to adjust the frame rate to 240 frames per second. Click the pink axes in order to insert vertical and horizontal axes. If necessary, these can be adjusted. For example, if the video was filmed at an angle. Click the icon with the blue measurement bar to insert a new calibration stick. We'll zoom in. I'm using the mouse to zoom. You can also use this tab up the top and drag the ends of the calibration stick to each end of the 50 centimeter ruler that's in the video. So even though you can't see the individual measurements on the ruler, because the ruler is 50 centimeters, we can double click on the size here of the measurement stick and set this to 0.5 meters. The next thing we want to do is to adjust the playhead to take it to the start of where you want to start measuring the motion of the mass from. I'm going to start just a little bit before the mass moves in order to capture the time period where the mass is stationary. But what we would do then if you were moving this was to right-click on this black triangle on the left of the playhead and select Start Frame to Slider. Then we drag the playhead along till we reach the end of the motion that we want to track. I'm going to stop tracking while the mass is still moving downwards and before it has a collision with the ground. Then I'm going to right-click on the black triangle on the right of the playhead and set the end frame to the slider. Drag the playhead back to the beginning. What I'm going to do then is to select Track, New Point Mass. That gives us some axes over here. I can hold down the Shift key and zoom in, again using the mouse or this zoom tab at the top. If I hold down the Shift key, I can then click the position. Here I'm choosing, I have a reflective area on my mass with a black dot in the middle, so I can set the first position to be where the position of that black dot is. Because I'm interested in this video just in vertical motion, rather than have this top graph show the horizontal position, I'm going to select the vertical velocity. If your video has a high frame rate, like this video, it's worth considering not tracking every frame. So here we could select 2 here, which would track every second frame, or 5 or more. Here I'm going to just track every frame. So I'll hold down the Shift key and then click the position of the mass. The camera I've used for this video appears to occasionally skip frames when recording at high speed, which is a source of noise in the tracked data. This can be manually smoothed by adjusting the tracked positions, like so, or simply averaged over when you are analysing the data. By right-clicking on the data and selecting Analyze, It is possible to fit a linear model to particular sections of the data. So here, because I have vertical velocity, if I click Analyze Curve Fitter Line, I get a linear fit here, where the gradient of this linear fit over here would be the acceleration of the mass at that point. So here we'd have an acceleration of about 1 meter per second. If we do this for the vertical position, then you can see we're seeing both sets of data here. We can change which data sets we're looking at by unticking this data here. You'll always get the data in this column here, but you can change which column is which by just dragging here. So here in order to look at the vertical data, I'm going to get rid of or not show the vertical velocity data and just show the position data. Because the velocity data is quite noisy, another thing we can do to get an average of the velocity is to click coordinates and slope, and then we'll get a little black line here that will read off the slope of this graph for us at different positions. So for particular times, we could use this feature to get an average value for the velocity, which you can see is quite smooth here compared to our velocity time data. The last thing we can look at is how we can export the data. You can see we have 3 columns of data here. The X component isn't particularly meaningful for our experiment here. So instead of showing the X component here, we could show the vertical velocity. And then we've got columns of data that we could export. So under File, you can click Export Data. And you get options whether you want a tab delimited or a comma delimiter, and then the data could be analyzed in a different software package.